All right. All right, so can we proceed?
Yes, ma'am, we can proceed.
Now, no noise. This is a cell connected in what? In series, right? Series means it's in a straight line. Okay, so we have E1, E2, and E3. We have R1, R2, and R3. That's the internal resistance. And I said earlier that internal resistance is the resistance associated with inside the what? The cell. So how do we get the effective EMF? The effective EMF is what? E1 plus E2 plus what? E3. Okay? Then that of the internal resistance becomes R1 plus R2 plus R3. Alright?
Yes.
So let's look at resistance EMF in what? In parallel. I can call it cells in parallel. Okay? Let me say parallel. Settle down. Okay, now this is what? Cells arranged in what? In parallel. Okay? Now this is E1, E2, and what? E3. I have my internal resistance. This is R1, R2, and R1, 3. How do we get the effective EMF? Who is that person that is talking? How do we get the effective EMF? E total is equal to what? E1, which is equal to what? E2, which is equal to what? E3. Do you understand? I'll explain why we have it that way. Then we have the internal resistance is 1 over R total is equal to what? 1 over R1 plus 1 over R2 plus 1 over R3. Do you understand? Now, why do we have these cells equals to each other when they are connected in parallel? It's because know that this end of a cell is positive and this end is what? Negative, right? So we have positive, negative, positive, negative. All the positive terminals are coming to one point, which is what? This is point A, and this is point what? B. All the positive terminals are coming to one point A, while these negative are coming to one point B. At the end, it now looks like it's a single word, cell. Do you understand what I just explained? So that is why they are all connected in one part and they are equal to each other. So if one is given to be 2 volts, all of them is going to be in what? Measured in 2 volts because they are connected in parallel. I'm not writing. Are we done? Come in quietly, I don't need noise. So right. If each cell has an EMF E, If each cell has an EMF E, comma, the net EMF of the parallel arrangement, the net EMF of the parallel arrangement is also E. The net EMF of the parallel arrangement is also E, that of a single cell. It's also what? E. That of a single cell. So this is what I just explained, that if they are connected in parallel, the net EMF, that is the total EMF, will be what? E, that of a single what? Cell. Alright? So we are done. Are we not reaching this side? Arrangement of resistors. But you should know what is a resistor. A resistor is a device that is specially designed to measure the amount of what? Resistance in a cell or in a circuit. Do you understand? A resistor is a device that is specially designed to measure the amount of what? Resistance. So I want to show you how we can arrange them. You already done that, right? That was SS1 work.
That's my SS1.
This is a resistor, and when you connect it in series, this is series connection. Series is in a straight line, right?
Yes, ma'am.
This is what? R1, R2, and what? R3. Okay, so how do we arrange it? The effective resistance is said to be what? R1 plus R2 plus R3. Then for parallel connection, we have what? Are people done with this side?
Yes.
Let's come out. Alright, now these are resistors connected in what? Parallel. The effective resistance becomes what?
1 over
1 over R
R2
theta is equal to
equals
what?
to 1 over R1 plus 1 over R2 plus 1 over R3.
Alright. What is it there? This class is noisy. What is the problem? I think the let's come as no one. I need attendance. Yeah,
the lady very long.
No, get back, get back. Take you 30 minutes to settle. Four resistors of resistances, or resistance of resistances, 1 ohm, 5 ohm, 3 ohm, and 4 ohm are connected in what? They are connected in what? Calculate the value of the combined what? Resistance, right? Okay, so how do we solve this type of problem? Now, because they are connected in what? In parallel. The formula is 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, right? Plus 1 over what? Okay, so I'll have 1 over what? 1 over what? 1 plus what? 1 over 5 plus what? 1 over 3 plus what? 1 over 4. So what next do we do? We find the LCM. What's the LCM? What's the LCM? What's the LCM? 60. 60? Okay. All right. 1 into 6 is going to give us what? 1 into 60. 60 times 1 plus 12 times 1 plus 20 times 1 plus times 1. Okay, so I have 1 over RT is equals to, can you add one error? 100 and what? 7. 107 over what?
60.
Now what are you looking for? You're going to do cross multiply, or I say therefore R total is equals to 60 over what? Can you divide?
0.5561.
0.561 ohms, right?
Yes.
We use the symbol for what? Ohms. All right. Are we done? So let's move into internal resistance of a cell. Now the internal resistance of a cell is small letter what? R, right? Is the opposition okay, let me say to current flow. Like if they're talking, I'll send you out. All right. Internal resistance of a cell, small letter R, is in opposition to current flow, where offered by the chemicals between the poles of what? Of the cell. So that is why you always see it beside this what? This EMF, that's the cell. Is that clear?
Yes.
Now, if you see this cell of EMF and the resistance offered between these poles of a cell, it is said to be what? Internal what? Resistance, because it is applicable inside the cell. Do you understand? Inside the pole of a cell. Now, any resistance outside this pole is said to be external. It's said to be what? External. So this is our internal resistance, and this is what? External resistance. Are we done?
No.
Okay, right. This internal resistance determines their maximum current. It determines the maximum current that can be supplied. It determines the maximum current that can be supplied by a cell of given EMF. By a cell of giving what? EMF. That can be supplied by a cell of giving EMF. Is that clear?
Yes.
Now, if I ask you, what is the EMF of a cell? SS3 years. What is the EMF of a cell? So if you are asked, you tell them electromotive force. I have an idea. Okay, the EMF of a cell, E, is the PG The EMF of a cell E is the PD across its terminals. Potential difference, that is PD. Across its terminals, when it is not delivering any current to an external circuit. Coming again. The EMF of a cell E is the PD across its terminals when it is not delivering any current to an external circuit. Are we there? When it is not delivering any what? Current to an external circuit. All right. Now, for example, a cell means battery, right?
Yes.
So one cell has an EMF of what? 1.5 volts. So if you have two cells connected in series, you have to calculate the effective EMF. It becomes 1.5 plus what?
1.5.
That is 3 what? 3 volts. Okay, so right. You should also remember that from Ohm's law, that V is equal to what? IR, right? What is V here? The potential what? In respect to say, we call it EMF. That means our EMF is equal to what? Do we get it? All right. Come, read the class. I don't need a single noise. I will send you out. Go and run those years. If I mix them with that language. So right, let's explain. Eagles Corner, hi, good morning, welcome. with the person singing. When I treat her for my next time, she don't do it. If one time, tell them to stop calling her. All right. The cell of EMFE supplies a current I to an external resistance R. Then the PD across R is known as what? Terminal PD. I told you we have two types of resistance here, internal and what? External. So the internal deals with the what? Poles of the cell, while the external deals with what? Outside the poles of the cell, right? Okay, so then the PD across the external resistance, that is the big R, is known as what? Terminal what? PD. Is that clear? And it's given by V is equals to E minus what? This, we have big V and what? This big V is called terminal what? PD. It is called terminal what? PD. That is the PD across what? The external resistance. Why this small one is called lost volts? That is the PD across the internal what? Resistance. Okay, so I will just say that this is what? Terminal PD, and is equals to what? From Ohm's law, V is equals to IR, so this is IR. Okay? E is EMF, small v is what? Lost volts, and is equals to I small what? R. Now I can bring them together to get a formula that I'm going to be using to solve some problems. When I have this, I'm going to replace with this, right? But before then, I want to carry this small b to go and meet this one by crossing the sign of equality, right? The sign will change. I'm going to have plus what is equals to what? Am I right? Am I right?
Yes.
Okay, so are you done with what I have for? Are we done? Okay, then I have the terminal PD plus lost volt is equals to what? The EMF. Now what is terminal PD? I big R, right? Plus what? Is equals to the EMF, right? Now something is common, which is what? The current. I can bring it out, and I'm left with what? Is equals to what? EMF, right? Then if I want to make EMF the subject, or to make current the subject, what do I do?
I go side by R plus
And if I go start by what?
R plus
This cancels this. Then the current flowing through the circuit is equals to E over what? All right. So what is I? Current. E is what? EMF. R is what?
external resistance.
And R is what?
Internal resistance.
So where I is current, E is EMF, R is what? And small r is what? right, are we done?
Yes.
Now, do you know what is terminal PD? Let me give you the definition. The terminal PD is defined as the PD between the terminals of a cell. Is defined as the PD, they are not writing, between the terminals of a cell when it is delivering current to an external circuit. Is defined as the PD between the terminals of a cell when it is delivering current to an external circuit. When it is delivering what? Current. Now, can you tell me the difference between terminal PD and EMF of a cell? You have the answer, you raise your hands up. What's the difference between terminal PD and EMF of a cell? Yes?
EMF of a cell does not divide to an external cell. It's like terminal divide to an external cell.
You know what it means? You can just get a cell, which is a battery, bring your voltmeter, connect the positive end to the positive end of what? The voltmeter. And also connect the negative end of it to the negative end of the voltmeter. You can measure what? The EMF. Even without connecting it to other components of the cell. That's what it means. Do you understand? Yes. So that is when we are performing an experiment on electricity, you'll be asked to measure what? The EMF, even before you start the experiment. Because you're supposed to know the EMF before you start. For example, I said that the EMF of a cell is 1.5 volts. So if you have two cells connected in series, it's going to be 1.5 plus what? 1.5, which is 3 volts. But when you measure it in real life, it's always less than what? 3 volts. Why? Should I repeat myself? I said that the EMF of one cell, for example, this is 1.5 volts, 1.5 volts, right? Yeah. They are connected in series. The question says, what is the EMF of the cell? They are supposed to get 1.5 plus 1.5, right? Which is 3 watts. That is mathematically. But in real life, you're going to get an EMF less than what? Why? Why is it so? Because no. Have you forgotten something that was attached to it?
Attached to it.
Yes. No. No. Is there no resistance inside the pole of a cell? Because of the internal resistance of the cell, it's reducing some part of current from flowing, so it will make it to be less. Even though it's closed, they're going to be having 2.85, 2.80, 2.90, this range. Okay? Do you understand? So that is what we are going to have because of what? The internal resistance inside the what? Cell. Is that clear? So let's solve a few examples on what we have done so far. A battery made up of 2 cells joined in series supplies current to an external resistance of 5 ohms. Are we there?
Yes.
If the EMF and internal resistance of the cell, of each cell, is 0.6 volts, 0.6 volts and 3 ohm, respectively, calculate the current flowing in the external resistor, the terminal PD resistor. Okay. The terminal PD and the lost voltage. Now we have this question. Can we solve? Please read what you have. Want to go?
Average made up of 2 cells, joined in series, supplies current and external resistance of 5 ohms. If the EMF and internal resistance of each cell is 0.6 volts and 3 ohms respectively, calculate the current flowing in the external resistor, internal and
All right. For us to solve this, we must draw our diagram, okay, to state what we have. They said 2 cells, right? So we have 2 cells. Or should I clean the box? You can label me. Let me clean, since you have the question. So we can solve. All right. The question says 2 cells, right?
Yes.
Okay, so I have the first one and the second one, right?
Yes.
So proceed. Proceed with the question. Let's analyze it.
supplies current and external resistance of 5 ohms.
Is that learning time?
Yes.
How possible?
Okay, we'll soon finish. Okay, external resistance of what?
5
5
ohms.
ohms.
So this is 5 ohms, okay? Proceed.
If the EMF and internal resistance of each cell is 0.6 volts and 3 ohms respectively.
So this is 0.6 volts, 0.6 volts, and this is what?
3 ohms.
3 ohm and 3 ohm, right?
Yes.
So what are we looking for?
Calculate the current flowing in the external resistor.
Now this is the current that we are looking for, right?
Yes.
So before we can solve for the current, we have two EMF connected in series. So we are going to solve for series connection, right?
Yes.
So the total or the effective EMF becomes E1 plus what? E2, right? That is 0.6 plus 0.6. What do we have? 1.2 volts. Now let's solve for the internal resistance. R total is equals to R1 plus R2, right? That is 3 plus 3, which will give me what? 6 ohms. Our external resistance is equals to what? So can we solve for the current? The current is equals to, what's the formula? Right?
Yes.
Okay. So what's my E?
1.6
Divided by what?
5 plus
Plus what?
6
So what do we have?
1.2
Divided by? Okay, so can we get our answer?
0.109.
0.109. Can we change it to two decimal places?
0.1
0. Amperes, right?
Yes.
That is the first question. What's the second one? The what? Terminal V. That is our big V, right?
Yes.
And our big V is equals to what? I big R, right?
Yes.
That is 0.11 times what? 5. So what do we have? 0.55 what? Volts. So the next one is what? That is our small what? Then it's equals to,
I small r
which is 0.1 times. Okay, what do we have? 0.6 is what?
volts.
Now, if you add these two together, it's going to give you the total EMF, which is what? 1.2. Is that okay?
Yes.
Is that clear?
Yes.
All right. All right, let me give you classwork. Classwork. I will solve it when next I see you again, okay? But just work on it. Are we ready?
Yes.
And this is also a jump question. A cell can supply current. A cell can supply current of 0.80 amperes, 0.80 amperes and 0.40 amperes through a 2 ohm, and a 5 ohm resistor respectively. Through a 2 ohm and a 5 ohm resistor respectively. Full stop. Calculate the internal resistance of the cell. Calculate the internal resistance of the cell. Is that clear?
Yes.
So, I'm going to look at it. We have two different cells that have different current and different external resistance, okay? So you look at it and see how you're going to solve it. All right. All right, can I have my attendance? Seriously, I paper complete. I mean, added your friends. I say, I'm here. And our class will start again, and I was there before 6 o'clock, 3 o'clock.
Thank you, ma. Enjoy your lesson. God bless you. Amen. I give you my notes. Thank you. Bye. Subscribe.
My Quran girl, let's come on. All right, we have come to the end of today's class. Thank you for staying and sticking to the end of this class. I will see you next time in the next one. Bye.
Bye.